Okay, good morning, everybody. We're going to continue learning about inequalities today, and we're going to talk about compound inequalities. Now, when you think of compound inequalities, think about a compound word, like doghouse. Okay? A doghouse is a compound word. It's two individual words, or two words that can be written individually, combined together as one. Well, it's the same thing with inequalities. We're going to take two individual inequalities, and we're going to combine them as one. The good news, the great news, is that all the skills are the same for solving. The bad news, if you don't know how to do those skills, you're going to have a little bit of a problem. So let's talk about the two different types of compound inequalities we can have. You can have what's called the AND inequality, or you can have what's called an OR inequality. Okay? And, or, the word OR. Yes, sir. Oh, I'm sorry, I think I got a question. Now, the graph of the compound inequality with the word AND, we're going to stick to AND here for a second, okay, contains the overlap of the graphs of the two inequalities that form the compound inequality. What does that mean? For example, let's take the individual inequality x is greater than or equal to 3. So x is greater than or equal to 3. That's going to be a closed circle on the 3. And it's greater than or equal to, so I'm going to shade it to the right. Is everyone with me so far? Let's take the other individual inequality. X is less than or equal to 7. So, closed circle on the 7. And that's going this way. Does that make sense? Does that make sense, guys? All right. Now, together, think about what's happening here. If I take this individual graph, okay, and I overlap it here, and I match it up just like this, don't they overlap right here? Did you see what I just did there, guys? Yes or no? Okay, so then together, it would be x is greater than or equal to 3, so that means it's going to the right, but it's also less than or equal to 7. And it's every single number in between 3 and 7. Yes, sir. This is the answer. Yes, this guy right here in blue. That's the compound inequality. Why? Because they took the x is greater than 3, and they took the x is less than or equal to 7, and they joined them together. And as you saw, when I put one graph on top of the other, the little blue highlighted section, that's the section that overlapped. Does that make sense? Okay. Now, you can rewrite the above compound inequality involving the AND as a single equality, such as, reading from the variable always, x is greater than or equal to 3, or, and, rather, x is less than or equal to 7. And that's how the graph goes. And you can see very clearly that that works. X is greater than 3 going that way, but it's also less than or equal to 7 going that way, and it's everything in between. So 3.1 would work, 5.7, 6, 6.9, 4.2. Will 2 be a solution in this? Will 9 be a solution in this? No. Very good. Okay? And again, you read it from the variable, guys. X is greater than or equal to 3 and less than or equal to 7. Does that make sense? Okay, that's the AND inequality. That's the AND. So just to make sure, if I tell you graph x is greater than or equal to negative 3, but less than or equal to 4. Well, you have your graph, 0, negative 3, and 4. X is greater than or equal to negative 3, close circle, I'm going to the right, bless you. But x is also less than or equal to 4. So, closed circle, going to the left. Hey, where do they intersect? Where do they overlap? Right here, between negative 3 and 4. Yes, sir. Okay, I didn't understand your question. What's a regular inequality? I don't know what that means. This is the way I taught you. This is what I'm teaching you. You mean just a single inequality by itself? Then it's just an open circle. Yes, of course. Why wouldn't you? It's any combination of any inequality. X is greater than negative 5, but less than 2. So, negative 5, 2, open circle, and x is greater than negative 5. Open circle, it's less than 2. Of course that can work. Thank you. That makes sense for the ands. Okay. Yes? Now the ors, the graph of the compound inequality with the word or, okay, or contains each graph of the two inequalities that form the compound inequality. Let's look at this one individually and then we'll put it together. X is less than negative 2. Open circle to the left. X is greater than or equal to 1. Close circle to the right. Let's put them together. X is less than negative 2 or x is greater than or equal to 1. Let's go ahead and take this again and just overlap it so you can really see what's going on. When I overlap this, okay, let's try this again. Let's try this again. Okay, here we go. When I overlap it, look at what happens. Look what I get. It's an or equation. It's saying that x is less than negative 2 or x is greater than or equal to 1. See that, guys? Now, you can rewrite the above compound inequality involving or as a single inequality such as, look at the way the x is. X is greater than negative 2, but it's also greater than or equal to 1. Very rarely do you see an or equation in this format. You can, though. I don't want you to think that every time it's in this format, it's an and, because it's not. It really depends. But usually, they show it like this at the bottom. Usually. But I want to show you both just in case to be prepared. So again, this individual compound inequality is read. X is greater than or equal to, greater than negative 2. Not greater than or equal to. That is wrong. X is greater than negative 2 or greater than or equal to 1. Okay? This is not the usual way to write or inequalities, though. They usually are written as such. X is greater than negative 2, and they actually put the word or x is greater than or equal to 1. Does that make sense so far? Okay? We're good? All right. Now, let's get to it. What compound inequality represents the phrase, graph the solutions? Okay, all real numbers that are greater, not greater than, but greater than negative 2 and less than 6. So how would I do that? How would I do that? How would I write all real numbers, which is going to be x, are greater than negative 2, but less than 6? Sir? You're going to have a negative 2? No. No. Always start from the variable. So guys, check it out. X. It's greater than negative 2, but it's also less than 6. Read and write from the variable. If you don't do that, guys, you're going to get it wrong, unfortunately. All real numbers that are less than 0 or greater than or equal to 5. Well, this time is this an and or an or? Okay, so you could write this two different ways. You can say x is less than 0 or greater than 5, equal to 5. That's one way. But since it's an or, you're also allowed to say x is less than 0 or x is greater than or equal to 5. You cannot do that for the and, but you can do that for the or. Does that make sense, gentlemen? Excuse me. All right, let's continue. What are the solutions now to negative 3, or rather m minus 4 is greater than or equal to negative 3 and less than negative 1? Very simple, guys. Again, if you know how to solve an equation, you got no worries. If you're still sticky on the equation, still not sure, this is going to be a little bit tougher. Do you guys remember that if I went ahead and just blocked this part off, if I just did that for a second, okay? Actually, well, okay, if I just block this off here, all right, and I add 4 to one side, what do I have to do to the other side? Hello, if I add 4 to one side, what do I have to do to the other side? Add 4, because whatever you do to one side of the equation, you do to the other, correct? Well, this time, I'm going to have two sides of this equation. So what do you think I'm going to have to do if I add 4 to the middle? You have to add it to all the sides. So now, 1, got my m because the 4's cancel, and we're done. So how would we read this properly? Anybody want to take a try? Sir? M is greater than or equal to 1? And less than 3. Okay, now, sometimes people are not going to know just by looking at this, just like we had proved before. This could be an and, or it could be an or. So what I would do is first graph it. Put your 0, here's your 1, here's your 3. M is greater than or equal to 1, so it goes to the right, but less than 3, open circle. So is this an and or an or? Now you know how to read this. M is greater than or equal to 1 and less than 3. Does that make sense, gentlemen? Okay. How about down here for number 3? What are the solutions of 3y minus 4 is greater than negative 2 and or less than 14? Well, I'm going to go ahead and add 2 to every side. I'm going to get my 0, 3y, 16, divide by 3 to both sides. So this is going to be 0, it's y, and that's going to be 5 and 1/3. Okay? Graph it first before you decide if it's an and or an or. Here's 0. Here is 5. Here is 6. Here's 5.5. This is about 5 and 1/3. Okay, so y is greater than 0, open circle to the right, but it's also less than or equal to 5/3, closed circle to the left. Yes? To the... I don't know why I did that. That is completely wrong. Everything I just did here is wrong. I wish I could erase that. I was actually testing you guys to see if you were paying attention. So good job. You guys did really well. It worked. No, I'm just kidding. For everyone out there in internet land, I'm sorry. I just did a very, very careless error because I did not pay attention. One of the things that I always tell you guys to do, so I apologize. There's no excuses. You're trying to get the y alone, so I apologize once again. You're adding 4 to everything. I don't know where I got the 2 from. So I've got 3y, 18, divided by 3. Again, I apologize. The real answer is right here. Sec. Okay, so now I've got my 0, I've got my 1, and I've got a 6. There's half, 2/3 is about right there. So y is greater than or equal to 2/3 to the right, but it's less than or equal to 6 to the left. So how would I read this correctly? Because yeah, open circle. How would I read this correctly then? Yeah. Y is greater than 2/3. Greater than or equal to 2/3. And less than 6. It's an and because it is in between two numbers. Does that make sense, boys? All right. Now, you know me, I like word problems. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86. You scored 86, 85, and 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th exam and final test? It's the 4th and final test. There's the last test to earn a B in the course. Now, in order to do this, guys, we got to go back in time a little bit and remember what the formula for average is. So what is the formula for average? Average is also known as mean. Okay? So, come on, guys. How do we find an average? Sir? Very good, son. It's the sum of values divided by the total number of values. So in this particular case, gentlemen, the average is going to be, you got an 86 plus an 85 plus an 80 plus, you don't know what you're going to get on test 4. So what do we call something we don't know? X. Very good. We got to divide that by how many total values do I have? Now, don't I want this to be between 84 and 86? So doesn't this whole value have to be greater than 84 or equal to, right? But it's also got to be less than or equal to 86. You see what I just did there? Does that make sense what I just did there? Yes, sir, my brother. Okay, which part? The part where I put the less thans or the whole thing from the beginning? Okay, thank you. Let's go back a little bit in time. Didn't we say that a B average is between 84 and 86? Didn't we say that this is the average? So don't we want this average right here, to be greater than 84, greater than or equal to 84, and also less than or equal to 86? Does that help, my brother? Does that make sense to everybody? Promise? Yes? No, well, you can score higher, but the whole point of this is he wants to earn a B. If you wanted to earn an A, then it'd be between 2 different values. But in this particular case, he's looking for a B because he's realistic. If you guys think he can get an A here, it's not going to work. Because even if he got 100 on the test, he's not going to get an A. So he's realistic. He knows he can only, or she can get only a B average. So he or she wants to make sure that they keep that average. So he or she needs to find out what's the minimum I need to get on this test to stay between an 84 and an 86. Does that make sense, guys? I was hoping these are the kind of things you do at home to see what you need on a test. This is how you find an average. So this average has to be between 84 and 86. Now, how do we solve this, guys? You can add them all up first. Okay, we can do that. What's 85 plus 80 plus 86? Let's use some logic. Okay, let's think about all those numbers you just threw out at me, guys. Let's think about it this way. What's 80 plus 80 plus 80? 240. What's 80 plus 11? What's 240 plus 11? 251. So 251 plus x over 4. Okay, now what? No, we already have 4 in the denominator. We can't distribute anything here yet. You can multiply 4, though, to both sides. Guys, I don't like the way you just loosely use words just to use them. Every time you guys think you have to multiply something, you say distribute. You don't distribute here. You multiply by 4 to both sides, so that cancels. 84 times 4 is going to be 320 and 16, so 336. And 320 and 24 is going to be 344. Is everyone with me here, guys? The distributive property would be something like this. And you multiply 6x plus 3xy. I suggest strongly you go back to the distributive property lesson in my videos and go over that, because you guys cannot continue to just say, oh, distributive property anytime you like. We learn math vocabulary for a reason, my brothers. Now, I'm going to subtract 251 to both sides, to all sides actually. Bingo. So we got 5, got to borrow, that's an 13, so that's an 85. And we got a 3, got to borrow, so that's a 93. So he or she can get a test. No, not can. In order to keep a B, has to get between an 85 and a 93. If they get an 84.5, they don't get it. Okay? If they get above a 93, they'll get above a B average. But to stay within the B average, that's what they have to earn. Does that make sense? You promise? Okay. Let's see. Next, what are the solutions of now? Here we go with the ORs. A lot of times it's really easy because you can see what the OR is. It's right there in front of your face. So here it's just Mickey Mouse solving each individual equation. So I got -2, I got 3x. I'm going to go pretty fast because you guys should know how to do this already. If not, you need to go back in time and learn. My brothers, please. So as you can see, I'm not even really explaining what I'm doing here because this should be common knowledge by now. I flipped the sign, remember, because I divided by a negative. And now I just graph these, my brothers. I got 0, I got 1, I got -3. X is less than -3, open circle to the left. X is greater than 1, open circle to the right. I mean, it doesn't get any easier than that, right? Now, does that make sense, guys? Like I said, I went fast. Was everyone able to keep up with the math? Awesome. Okay, let's go again now for example 5. I'm going to just fly through it. Hopefully you guys can see what I'm doing. Why did I flip here? Because I divided by a negative. Very good, my brother. Good job. I got to flip here, right? Why not? I have a negative there. Oh, but you're not dividing by a negative. Yes. You got to divide by a negative or multiply by a negative to flip the inequality sign. Great job, gentlemen. So here's 0, here's 3, here's -2. greater than open circle to the right, y is less than or equal to -2, closed circle to the left. Does that make sense, gentlemen? You got this, man? You look a little lost. Yes, you're lost, or yes, you've got this? Yes. Okay. Questions? Okay. I guess we can, yes. This is the end of the slide, so we are done. I'll put some practice problems down on the board. Thank you for a good lesson. Let me just save it real quick. Thank you.